let's cover number 26, function solving for y, which is f of x in this case, and for x, and this is our student guided notes. A function is a rule, this is a definition, a function is a rule for a relationship between an input or independent quantity and an output or a dependent quantity. Now, what you need to understand before I get any further is your input is usually understood to be x. All right, your independent quantity is x. Your output, it's not always x, but in the case of what we're going to be doing today, it's going to be x for a good portion of this. The next one is the output, and the output is typically our y for understanding. But now I'm telling you that it's not just y, it's f of x, which means it's a function of x. So function notation is used to indicate a functional relationship between two quantities where it has the function name, in this case f, the input, which is our x, and that is equal to our output, which is our y. And it says would refer to the function f that corresponds to the ordered pair xy. X decides what y is. Y does not decide what x is. Okay? For each x, there can only be one y. So starting off with our first one, to understand the concept of a function. It says the number of days in a month is, so I'm going to write number of days, is means equals, function of the name of the month. So I'm going to write the function name as f, and I'm going to write name of month. Now this is a lot of words, and math people don't like to use a lot of words when we're describing equations or equalities. So I want to make this simpler. Could I make this just d for days and my function of m for a month? Okay, this makes a little bit more sense to me. Now our m should only be able to produce one answer for our d. I have to start off with what my input is. The input is always inside the parentheses. So as an example, I was born in June. So if I say the function of June, I'm going to write my d over here, is equal to what? It's how many days are in June. And that answer is 30. Say you were born in December. Then the function of December is going to be equal to 31. All right, we're not going to talk about February. February's got its own issues, and we're not going to even play with it. So this is a function because each one of the months only has one answer for the number of days in that month. Now, how can I show you that something's not a function? What if I went the other direction? What if I wanted to say, okay, what's the function of the number of days in the month is 30? My gosh, how many answers can we have? 30 days has September, April, June, and November. So we've got quite a few months that could be answers for the name of the month if that's what I wanted to write over here. And you can't have more than one answer to plug in here. We've got November, we've got June, 30 days, April, June, and November. Yeah, we've got a few. We've got more than one, and that's all that matters, is if you have more than one, this cannot be a function. All right? So I would never want to do this. This guarantees that I am not using a function if I can have more than one answer for my output. Okay? By the way, my answer for this is that. Okay? Just because I mean, you could have written it like this, but this is more accurate mathematically. Okay? And then these other two pieces are me showing you how I verified that it was correct. Because what if I'd have written m is equal to f of d, like the concept I just did here? It wouldn't have worked with my examples. So let's go to example 2. And this is something you're going to see as well in your next class. A function p of n, so this is going to be comparable to our f of x, where our n is our input, okay, and whatever p of n is equal to is our output. It's our y value. And if p of n gives the number of police officers in a town in years after 2000. What does P of 5 equal 300 tell us? Okay, well, the 5 tells me that n equals 5 because the 5 is in the place where the n was, correct? So that means 5 years after 2000 because it's in years after 2000. Well, how do I find out what year that is? I have to add 2000 plus 5. So this happened in the year 2005. What is this telling us? What is the equal telling us? Well, it gives us the number of police officers in a town. So this is the number of cops, the number of police officers in the town 5 years after the year 2000. Now, I don't want you to tell me 5 years after 2000. I want you to say in 2005, the number, I'm going to use their words, the number of police officers in a town was, pick a verb, 300. You're going to need to give me a sentence, okay? All right, let's go to the next one. Using the table, evaluate G of 3. We're going to just start with that. I need to know first, what is my function? My function is G of n. So if I have G of n as a function, what has taken the place of my n? My n is 3. So whenever I see evaluate G of 3, I'm going to start with it down here. The question I always ask myself every stinking time is when n, let's try this again, too many n's. When n is equal to 3, which is the case here, what's the function? What's G of n? Okay, and you should write this down because you can use this every stinking time, okay? When n is equal to 3, what's G of n? Now, the letters are going to change, the numbers are going to change, but this is the concept. You're going to want to say when whatever the value is for the variable is equal to what's inside the parenthesis, what is the function itself? Well, let's look at that. I'm going to cover up the G of n portion and just look at n. Find where n is 3, right here. Here is where n is 3. So now we need to say, okay, what is the function when n is 3? It is 7. So G of 3 is equal to 7. That is the answer for that one. Now B, I'm going to ask a different question. It says determine n, so it means we're looking for the inside value when G of n is equal to 6. They're telling us what the function is. So here's the question I always ask myself. When G of n is equal to 6, what's n? And I'm going to use that exact same method. I'm going to cover up my n because we don't know what it is. I need to find where G of n is equal to 6. All right, so I'm going to use my highlighter. G of n is equal to 6 here, but wait, there's more. G of n is also equal to 6 here. So we should have two different n values. If we don't, then we don't have a function. All right, so when I move my pen, when G of n is 6, n is 2, and when G of n is 6, n is 4. So you can write your answers like this. N is equal to 2, n is equal to 4, or since you've all taken algebra before, you could write G of 2 is equal to 6 and G of 4 is equal to 6. Both of these methods are correct. You pick which one you like and go with it. I do not expect you to write both of these. That's why the or is there. Okay? So make sure you have this on hand because you're going to see another one of these and I'm going to want you to attempt it on your own. Pause the video, attempt it on your own, and then come back. So if you pause my video right now, you can keep this up on your screen while you're working through this next one. So pause your video. Hopefully you paused your video and then come back to see how you did. If not, rewind a little bit. All right, for this next one, we're going to use the table. I'm going to use the same words. I use these same words every time I teach this, whether it is in this class or in the problem solving class. And it is these words, because this is what I use myself when I'm looking at these tables, trying to figure out which one's which. Evaluate k of 4. Well, that means my function is k of m. And my question I ask myself for this is, when m is 4, what's the function? What's k of m? Okay. Do I have another highlighter, I wonder? I don't even know what I just did. Oh, there's my yellow. Where is my... Oh, that's all I got is yellow. All right, well, we'll just stick with what we got. So for this one, I'm going to hide my k of m and just look at my m. I need to find where m is 4. Right there. There's my m is 4. I'm going to hold the spot, and then I need to remove my pen and find out what k of m is. K of m is 51. So k of 4 is equal to 51. All right. The next one. Determine m when k of m is 8. So here's the question I ask myself. When k of m is equal to 8, what's m? Okay, be careful. Sometimes there's more than one. So again, now I'm going to hide my m. I'm going to highlight where my k of m is equal to 8. Right there, it looks like we only have one of them. And then once I move my pen, I know that m is 0. So that means that m is 0, or you could write k of 0 is equal to 8. These are both correct. It doesn't matter which one you choose. You make that decision. All right, we're going to do the same stinking thing with graphs. All right, and I always ask the same questions. With graphs, it's a little bit easier because we have x, y, and that's the only thing you're going to usually see. Not always, but sometimes there's other things, but usually all we see is x and y because we've got an x, y Cartesian coordinate system. So if you're going to evaluate f of 2, well, what is that 2 replacing? It's replacing the x. So this is f of x. Again, with an evaluation one, I say when x is equal to 2, what's f of x? Now, you can't ask what's f of x if you don't know that f of x is y. So instead of saying f of x, you could say what's y? All right, because they are the same thing. Y is just a function of x. All right, y is a function of x. So now I'm going to say, okay, where is x equal to 2? X is equal to 2 right here. Fantastic. I don't want to just see it on the x-axis. I need to see where that is on the graph. And there it is on the graph. Graphing is a little bit easier because we know that these are ordered pairs. And I've chosen that when x is 2, what is the matching coordinate, the matching y on the coordinate for this graph? And that is 1. So f of 2 is equal to 1. All right? So when x is 2, y is 1. That answered the question. Do not write it like this. Write f of 2 is equal to 1. This is your answer. This, however, will probably help you understand finding that y value. The next one, we're going to be given y, and we're going to be looking for x. So it says determine x when f of x, which is also y, is equal to 4. All right? So now I have to find, I'm going to ask the same questions. When y is 4, what's x? So I need to find on my y-axis where 4 is. It's right here. That's fantastic, but I need to see it on the graph. So I've got this point, but wait, there's more. I've got this one as well. So I know that my y values are 4. What are my x values for these two? That's what I'm looking for. The first one is -1, and the second one is 3. So I'm going to write, instead of leaving it like this, I'm going to write x is equal to -1 and x is equal to 3, or, this is the answer, or you can write f of -1 is equal to 4 and f of 3 is equal to 4. This is the answers as well. You should choose which way you're going to write it. This is not your option. You need to write it one of these two ways. Okay? So I want you to pause the video, use your paper, and do the next one on your own, and then come back to see how you did. Okay? All right, let's look at the next one. Given the graph below, evaluate f of 1. So this means it's replacing the x. When x is 1, what's the function? What's f of x or y? It's the same thing. So we know that x is 1. What is our y value? Here is x equals 1. Here's my point right there on the x-axis. And so that means my y value is 0. Again, you can't use this as your answer. You need to say that f of 1, the function of 1, is 0. The next one is determining x, so we need to know what our x values are when f of x is equal to 1. So what's x when y is equal to 1? And again, if it helps you, write your 1 value over here and find out what your x is. So now I have to look at my y-axis. Where is that 1? Right there. Find it on your graph. Well, here's 1 right here, but we have a second one right there. I need to know what both of the x values are for these 2 points. This one is on the x equals 0 portion. So x is 0, but then I have another one right here where I have 1 for y, and that is where x is 2. This is not an option for your answer. You need to say x is equal to 0 and x is equal to 2, or you can say f of 0 is equal to 1 and f of 2 is equal to 1. Again, you decide which method you're going to answer it with. All right? If you have any questions as you're going through this, please make sure you're writing notes so that we can discuss it before the exam or before the homework. All right? Given the function k of t is equal to 2t plus 5. Now I'm going to go ahead and do both of these. All right? I did them separately in class. I did this one, I had you do this one, then I did this one, and then you did this one. But I'm going to do both of these so that you'll have both examples to leave up on your screen as you do the next one, and that way you can come back and see how you did. Given the function k of t is equal to 2t plus 5, what is taking the place, what was here instead of 8? T was. So this is a representation of t is equal to 8. That means everywhere there's a t in this equation, you need to replace it with 8. So k of 8 is equal to 2. Oh, we got a t, so I need to replace that with 8 plus 5. I know to put this in parentheses because this 2 is attached to t by what? Multiplication. So I automatically put it in parentheses. Okay? Now, you do not solve for anything. There's no solving for evaluations. You just hit the equal sign. This stays as k of 8. You're not solving for k. You're just simplifying the right side, and that is it. 2 times 8 is 16. Bring down your plus 5. And then 16 plus 5 is 21. So k of 8 is equal to 21. Yes, you could have put this entire thing in your calculator to get 21. But if you didn't show any steps, you couldn't get any partial credit. Okay? Just letting you know that. Let's go to the next one. It says determine t when k of t is equal to 1. So we need to know what the input is here because we know the output is 1. Well, for this one, I like to rewrite the entire equation. Now, the thing that students have told me helps them understand this the best is we're going to be substitute. We're going to substitute where the k of t is, which is this right here. They are the same thing. This is k of t. This is k of t. Well, this is telling me that k of t is equal to 1. So that means this k of t is going to go away, and I'm going to replace it with 1, and then rewrite the equation. Now this one, you're going to solve for the variable. Solve, in this case, for t. The other one we didn't solve for t. We simplified. This one we have to solve for the variable. Now I have a 2 attached by multiplication and I have a 5 added. We have to go opposite for order of operations, so we have to subtract 5 from both sides. 1 minus 5, the signs are different, so we subtract and take the sign of the larger number. Bring down your 2t. Make sure you've got your equal sign. 2 is attached to t by multiplication, so we're going to divide both sides by 2. And t is equal to, negative divided by positive is negative, 4 divided by 2 is 2. So t is equal to negative 2. You can leave this as your answer, or you could rewrite it as k of negative 2 is equal to, equal to 1. I had to think through that for a moment. So those are your two options. I do not expect both of these answers. You decide which one you want to present, okay? I want you to go through this. If there's anything you don't understand, we need to talk about it. But I want you to struggle. I want you to struggle. You're going to struggle if you don't remember how to do this. You're going to need to use my example, and I want you to do number 8, okay, using my example. If you don't remember how to do it, rewind my video and watch me do this one again to help guide you through number 8, all right? Just because I want you to give it the best chance possible before you come watch me do it, all right? That's what learning's about. So pause your video. I'm going to go to the next one. All right. Given the function g of m is equal to 5m plus 17, we want to evaluate g of 9. Well, that 9 has taken the place of m. That means that everywhere there's an m, I want to replace it with 9. So g of 9 is equal to 5. This m is multiplied to 5. So times 9 plus 17. Remember, we are not solving here. We're simplifying. So just bring down that g of 9 for each of your pieces, and we're going to just simplify. 5 times 9 is 45. I don't expect you to know these. I know you don't have everything memorized. Use your calculators, please. And then 45 plus 17. 7, 8, 9, 10, 11, 12. So 62. So g of 9 is equal to 62. If you input a 9, you get back a 62. Our next one, we're going to determine m when g of m is equal to 2. Again, I rewrite the entire thing. G of m is equal to 5m plus 17. I notice that this is g of m, this is g of m. We're just replacing this one with what g of m is equal to, and they're saying it's equal to 2. And then I'm going to solve, not simplify, I'm going to solve for my variable. I'm going to solve for m, solve for my variable. I've got 5 that's multiplied, 17's added, so I have to subtract 17 from both sides. 2 minus 17, the signs are different, so I subtract. That gives me 15, and take the sign of the larger number. Bring down my 5m. These are gone. 5's attached to m by multiplication, so I need to divide both sides by 5. 15 divided by 5 is 3. Negative divided by positive is a negative. So this is an answer, again, or you can write g of negative 3 is equal to 2. These are both answers. They're the same thing. You would, again, decide which representation you want to provide. All right, this last one, I'm not asking you to do anything. I'm asking you to understand, okay? I'm asking you to understand whether something is increasing, decreasing, or constant. If, as you move from left to right, so left is this side, right is this side over here. So I always think of this as a roller coaster. If I'm riding on a roller coaster and I hit the line and it's going up like you would in a roller coaster, that means that function is increasing. Same thing for the second one. You hit that line and it's starting to go up. That is an increase. These are both increasing functions. All right. It's a little harder to see it over here with the numbers because you can't use your roller coaster concept. You have to see, okay, as my x's are going up, 0, 1, 2, 3, that's going up. My outputs, this is input, my outputs are also going up. 4, 6, 12, 24. They're going up. So this is an increasing function. A decreasing function is, again, from left to right. As the inputs increase, the outputs get smaller. Roller coaster concept. Looking at a graph from left to right, you hit that roller coaster and it's going down, that is a decreasing function. Again, hit the roller coaster, you're going down, decreasing function. Now this one is your input is going up. This needs to be going up. Your output should be going down if it's a decreasing function, and it is. 5 is less than 10, 0 is less than 5, negative 5 is less than 0. So this side's going up, this side's going down, so this is a decreasing function. Okay, let's look at the last one here. I want to make this a little bit easier to see. Here are the lines that I'm referencing. That's a line, and that's a line. The other two are representation of your x, y axis. And this should have arrows, but I want to make sure you understand that these are the lines we're looking at. Now, if you're on your roller coaster, you're on the flat part. You're on the part where you're just you've either just landed and you're going straight through, or you're just getting started. These are constant functions. There's no going up, there's no going down. It's just constant. All right, we will not have any for vertical because those are not functions. Again, as your x values, your inputs going up, your output is consistently staying the same, which means it is a constant function. All right, that is it for this section. I think we're done for the semester, and I will see y'all in class for the exam. Please message me if you need some help. I'm happy to meet with you on Zoom. If you need help for your homework, if you need help with understanding the lectures, please let me know, or we can meet up on campus. I'm happy with that as well. Whatever is best for you. All right, just keep me in the loop and let me do whatever you need to help. All right, see you soon.